about the decision trees. So we understood how the decision tree works. At least, given any decision tree, we have to just read through the conditions that it has put. So, for example, you start from the start node. When you go into the one of the decision tree node, you can see the question. The question here is credit. What is the credit? Is it excellent, fair, or poor? Based on that, we go into the corresponding branch. Once we go into that branch, again we do the same thing. We ask another question. For that question, based on the answer, we go into different branches. Finally, we go into some decision. So from start to end, we keep on asking questions. Finally, we take a decision. Once we take a decision, it could be one of the classes that we want to predict. So risky, safe, only these two are there. Others are already repeated. This is also safe. These two are safe. These two are risky. These three are risky. All of these are same. They are all repeated. So what is happening here is you have a list of decision nodes in the tree, which will take some, which will ask for some criteria. So for example, it is asking for whether the credit history is good, bad, or whatever, excellent, fair, or poor. Based on that, again you ask another decision, another question. So finally, based on all these questions, you take a decision. It's more like an interrogation. So if you see any movies where CIA is involved, they'll ask a lot of questions. They'll keep on asking questions. Finally, based on questions, based on the answers, they'll take a decision. Even for any interviews or anything, they'll keep on asking questions. You go to an interview, the interviewer will ask you a lot of questions. Finally, based on all the answers, that interviewer will take a decision. So all these are implicitly you are doing the same thing, except that you are not drawing a tree. In this case, you are also drawing a tree. That is the only difference. Otherwise, both are same. Interviewer asking a list of questions and finally taking a decision whether accept or reject the interviewee is same as this decision tree, except that he is doing mentally. He is not drawing this tree and deciding. Is this clear? Any questions?
No questions.
Yeah, it's clear, Sumit.
Okay. So in this decision tree, generally this is a terminology. The first node is called root. This is called root of the tree. Then these are all decision stumps. Decision stump. And the leaf. So if you see these are the leaves. Why do I call these as a leaf? From any of these nodes, you are not getting any more branches. So because when you don't have any more branches that are coming out from the tree from a different node, then you call those as a leaf. So leaves are something that you'll see at the end of the tree, at the bottom of the tree. So whenever there is a decision stump decision, let me remove all this CA stuff. Just for your information, I gave this. Sorry. Yeah. So this is called decision stump. Any decision you are taking, any questions you are asking, that is called decision stump. It's very simple. Now, in tree terminology, this is also called intermediate tree nodes. Intermediary nodes in the terminology of a normal tree. And each decision stump will have multiple branches. So this is a branch. So from one node, you are having a branch. And finally, these are called leaves. Leaves. Or let me call leaf nodes. Okay, that is how. What happened to this? 1 second. Did I do anything wrong? Let me close and open. Somehow there is a problem with this. Went through everything of each of these things. I go beyond. And this one. Let me write again. Sorry for that. So this is the root. This is the branch. Then this is one decision stump. Then this is leaf nodes. All of these are leaf nodes. Okay. That is about the tree, how the tree looks like. Now, what does this decision tree represent? It finally represents a series of conditions. Based on the based on each condition, you take a different branch, and finally you arrive at some conclusion. That conclusion is either the loan is safe to give or risky to give in this case. So you get to some conclusion. So you can see, if you think about how the classification works, if you see how classification works, these two are nothing but two categories, and you're trying to predict one of the category, whether it is a risky loan or safe loan. Both of these can be thought about as categories. Now once we have two categories, we can predict one of those two categories using a decision tree. Now how to do that? So it is nothing but decision tree is a classification technique. It can be also used for regression. We'll look into those, but it is primarily it is a classification technique. If you want, you can use it for regression also by some small modifications. For now, let's not worry about the classification, regression. We'll just worry about the classification technique. Is this clear? Okay, so you can see what this guy is saying is, so this risky is saying if the credit is fair and the term is less than 3 years, then we are predicting as risky. That's what he is saying here. 3-year loans with fair credit history are risky. Similarly, if you go to the other risky item, here 3-year loans when the income is high and credit is poor are also risky. So what you are saying is, finally, whatever is your decision, you can try to go back and retrace your tree. For example, what about you went, so you have a data point and you predicted for that person the loan is risky to give. Now that person may come back and ask, why did it happen that my my application is rejected? Why is my application rejected? This is a very common question across any industry, right? So when someone applies for a loan and he gets rejected, he might come back and ask, why is it that my loan has been is not approved? Why is it rejected? Now, to answer that question, I can retrace this tree back to the root. Let's go back and try. So income is low. I go back again. Credit is poor. And it is a root node. So there is nothing to go there. So what happened? So your income is low. And you have poor credit history. I can tell him the reason. The reason your application is rejected is we don't take applicants who is having poor credit history and low income. Because of that, your application is rejected. Now compare this with the logistic regression. If the same person comes back and asks you why you rejected the my application, it is very difficult for anyone to explain why it is rejected, because if you see the logistic regression formula, it is log p by 1 minus p in equal to beta naught plus beta 1 x1 plus beta 2 x2. Beta 2 x2 plus beta 3 x3. We have three variables here. One is credit, income, and term. You can call this one as credit, income, term. 3x variables are there. Now, if the same person asks you the question about why it is his loan is not why his loan application is rejected, and at the back end you used logistic regression instead of decision tree, what happens? You cannot explain. You cannot say just because your beta 3 is very bad, your application cannot be processed. It doesn't make any sense for anyone. Are you clear? What is the advantage with decision tree? It's very easy to interpret. Is it clear?
Yeah, it's Sandeep.
Yeah. You cannot say your probability of, if it is in logistic regression, your P is very, very small, sir. That's why we rejected. If you say like that, he'll go mad. So don't say that. So out of all the many different machine learning techniques, This is the highly interpretable, the best decision, the best classification technique that you can use is decision tree. So actually for this same problem, I can also use logistic regression. I can also use decision tree. But what I would suggest is always there will be different, many different classification techniques, many different regression techniques. So the first question you should ask me is, which one should I use? Should I use for this problem decision tree or logistic regression? Or there are many other techniques that I'm going to tell you. Any of those techniques, what should I use first of all? So the answer to that question is, I should use any technique that is good on the given data set. So maybe for the given data set, logistic regression is working very well compared to any other regression technique. Logistic regression is working very well than decision trees. Then use logistic regression. What it means is you try out all the different classification techniques. If your given problem is classification problem, try out all the given classification problems, classification techniques. One technique will suit the data very well than any other technique. Use that technique. Now, how would I know that that one technique is doing very good? The reason is, the answer to that is use accuracy, precision, recall, F1 score. We talked about all those things. Use one metric, one of them. I would prefer to go with always F1 score if it is a classification. So use F1 score. Use the best F1 score. Use the model which is having the best F1 score. If logistic regression is having the best F1 score out of all the different classification techniques, use that technique. Do not use the other techniques. Is it clear? Vijay, are you clear?
Yes, Sandeep.
So you just simply have to try out all the different algorithms, all the different techniques that I have taught you. One of the technique will work very well on the training data set and test data set as well. That technique is what you have to use. If it is only working on training data set, do not use that. Very simple. It should work very well on test data set, basically.
So one algorithm should work best on both training and test, right? We don't just pick the one that works best on the test.
Yes, that is true.
So it should work on both the training and.
So when you're applying any machine learning technique, the minimum that you want to manage is the trained data set. So what I implicitly assume is, on the trained data set, it should work very well, first of all. Then comes the test data set. So it works very well on the trained data set. You tune that machine learning model. For example, you took logistic regression. You keep on tuning that machine learning, that logistic regression model, as long as it works very well on the trained data set. Now, once it works very well on the trained data set, you do a test on the test data set. Before that, you can use cross validation, all those techniques. Okay, we already used one cross validation technique, if you remember. So what you do? Train, test. When you are using cross validation, train is divided into n parts, let's say 5 parts. One part is taken as the validation data set. Other 4 parts are taken as the train data set. You apply the model on train data set, validate it on the validation data set, which is one part of this train data set. Now, which model you should choose within that logistic regression model? you have various tuning parameters. Use all the tuning parameters. I think I have already shown you how C works. Did I show you? Logistic regression C, maybe I did. Yeah, I showed you how C works on ridge regression, right? It works the same way. Logistic regression also has a C parameter. Did I show you or not?
I don't think so.
Okay, maybe I did not see because I was also not sure. Maybe I did not show you. Yeah, in this I did not show. Yeah, I did not show you. Don't worry about it. For example, if instead of logistic regression, you can take the other one, which is ridge regression. Okay, let's take ridge. In ridge, we saw alpha, right? We saw alpha.
Yeah, Sandeep.
So you take alpha, try out different alphas on trained dataset. Whichever alpha is working very well for validation dataset, that is the alpha you have to use. You have within this trained dataset, you have trained dataset and validation dataset. Whichever alpha is giving the best MS residual, you are going to use that alpha. That is based on validation dataset. So on trained dataset, you apply the model. On validation dataset, what you are going to do is you are going to try out and say whether it is working very well or not for that alpha. Now you choose the alpha which is working very well on the validation dataset. Now once you do that, you know that ridge regression is giving this much of error on test dataset. You apply this entire, once you chose one alpha, that alpha you use that you start using that alpha and um, perform another test on test dataset. You get a final MS residual. Keep the test set. Now you start using another regression model, for example, linear regression or lasso regression, for example. Again, try out different alphas. Fix one alpha based on the validation dataset. Do a test on the test dataset. Now the question is, which one should I use? Should I use the ridge regression or should I use the lasso regression? How do I know that? Use the model which is working very well on the test dataset. If MS residual is lesser on ridge regression compared to lasso regression, you should use ridge regression. MS residual is something that you should always aim for lesser value. So if you have two models, ridge regression and lasso regression, which model should you use? Whichever is doing very well on the test dataset. Are you clear, Vijay, with this example now?
Yes, Sandeep.
Okay, I'm clearing this off because that's not our topic of interest. Just to explain you which model to use, I just took the ridge and lasso example. Just remind me about the C parameter in logistic regression. Remind me once we are done with the decision trees and random forests. Then I'll explain how the C parameter works. Maybe I forgot to include that in the Python scripts. Okay, I do not have that Python script, it seems, but that's okay. We'll try to understand and we'll try to run an example in the class itself. That is also fine. Okay, just remind me after random forest is done. Just remember that name. Once random forest is done, just remind me. Now, C parameter in logistic regression is nothing but it is similar to alpha, just a reverse. Okay, we'll get to know about that. Now, how to score an application? So one person gave an application as his credit is poor, his income is high, and he wants a loan for 5 years. That is his term. This is a new application. You already built your decision tree. Assuming that you already built your decision tree, for a new application, how do you score a new application and say that whether you can give him a loan or you cannot give him a loan? How do you know that? Now again, the same way we can go. Always start with the root node. There is nothing to do in the root node anyway. Then go to the credit. What is his credit? Poor. So you should take this branch. Then for income, again go back and check your application. Income is high. So you go to this branch. And then again, the term is 5 years. So you go to this branch. So your decision is going to be safe, which means you are going to approve that person's loan and give him a tell him that your application is processed. So this is how you can once the decision tree is built, this is how you can score his application and give a decision automatically. And if you go back and see what we wanted an intelligent review system which will automatically do all the loan application processing by itself, and based on the application, you have to score him as whether it is a safe to give him a loan, or very risky because he's a defaulter. So you wanted this system. This system is just replaced by this tree. You just replace that system by this tree and you already have what you wanted. That's what he's doing here. Given any loan application, you can do any prediction, whatever you want. Now the question is how to build this tree. Yeah, I know very well that this tree works. If I have such a tree, I can predict any class that I want, whether it is a safe or risky, or whether that person is going to survive or die. Or it could be very simple that am I holding a laptop or a tab? Yes, I can do that, right? So tomorrow, if I can apply the same logic to any images and automatically say that I am holding a laptop versus I am holding a tab, that is also one more intelligent system. It is a classification technique. Okay. So there are many decisions in this world. Am I going to buy tea or coffee? That is also one more decision point I need, because my grocery store, I need to identify people who are buying coffee versus tea, so that I can as a store I can buy a particular amount of coffee versus particular amount of tea. If coffee sales are going to be higher than tea sales, I should stock more coffee than tea. All these decisions are what I need to do. Everyday decisions are always going to be classification. Mostly 90% of your decisions are classification techniques. Only 10% of the techniques are regression techniques, because that is the nature of the system. So for example, you woke up and you want to dress up, and you have let's say 3 different pairs of jeans. Now your decision is going to be, should I wear jeans number 1, number 2, or number 3? This is a decision that you are going to take. Again, you want to go to office. Should I take an office cab or should I take a Uber, or should I take a personal vehicle? That is another decision. Again, it is a classification. It's not regression. So your everyday decisions are going to be most likely classification most likely, and only in a few cases it is going to be regression. Okay, where is it regression? That is another question. Okay, let me give you another example. What is the price that I have to pay? What is the minimum price that I can pay for a movie ticket? I want to watch a movie, let's say, X-Men, new upcoming X-Men series, one of the movie, and or even Avengers movie that already came up. I want to watch Avengers, and I want to pay lesser money. What is the average money that I can pay so that I can watch Avengers near to my location? So there are 100 theaters around me. I want to pay lesser amount. It should be nearer. What is the best price I can get? It could be regression now. Okay. Any questions so far? What is regression and classification? I already explained what is regression and classification. I am just telling you again why regression is less likely to use in reality than the classification techniques. Classification techniques is mostly 90-95% of your time you'll be working on classification. 5% of the time you'll be working on regression. Any questions?
No, I'm clear, Sandeep.
Vijay, are you also clear?
Yes, Sandeep.
Then I'll ask you, both of you, some questions. Give me some decisions that you are taking in real life. Let's try to write down. That is a better way, right? Who is going to start? We are going to identify whether it is a classification or whether it is a classification or regression. That is a second item. But the first item I want to ask is, what is the decision that you take? Any decision. It could be very implicit decision, like should I buy coffee or tea? That you take without asking anyone. You just think for a second and take the decision yourself. It is most likely an implicit decision. Decisions we generally take. In real life. Anyone?
We take we take decision based on the whether to go out or not.
Yeah, whether to step out or not. Step out of house or not. Yeah, that is most likely a very implicit decision, right?
Yes, Sandeep.
It is general. So, for example, you realized uh, one of the grocery item that you need at home is not present. Now, the first station you think about, first station you want to take out is whether I should get out of the house and buy that grocery item, or should I live with whatever I whatever I have. What else?
Whether to buy a vehicle based on its condition. I mean, to buy a vehicle based on its condition.
Okay. Should I buy this vehicle? Whatever is that vehicle? I saw some vehicle. Should I buy it or not? Any more? Vijay?
What fruit to eat, apple or banana?
Yeah, that is a always there, right? You have a lot of things. Which fruit to eat? Okay. Then what?
Decision to choose which technology has better career growth.
Yeah, that is a which of the many technologies to use? Now let's talk about whether it is a classification or a regression. Is it a classification or regression? Whether to step out of your house or not? Vijay?
Classification only.
Yeah.
Sorry.
Yeah, no worries. Let's ask the next question to Vijay. Classification. Should I buy this vehicle? What about this, Vijay?
Would it be um, in the would it be regression because you're comparing a lot of things, or would it be classification to make it simple whether it's yes or no?
No, what is the answer for this? Should I buy this vehicle? In general, do not worry about classification or regression. In general, should I buy this vehicle? If I ask you, what will be your possible answers?
Yes or no?
Then what is the technique?
Classification.
Very simple. So talk about the answer. If your
Okay.
answer is saying, should I buy this vehicle? If I'm saying $2,000, of course, it doesn't make sense. If I ask you, should I buy this vehicle? And if you answer me saying that, $2,000, it doesn't make any sense. But assuming that it makes sense, then if you are getting some continuous variable, then you call it as a regression. If you are getting a categorical variable as an answer, then call it as a classification. In this case, the answer is, should I buy this vehicle? The answer is classification. But if I change the question a little,
Our parents also.
what is the best price for this vehicle? What would it be? What is the best price for this vehicle? I have a vehicle. I saw some vehicle. Whether it is a uh, first buy or second buy, I don't care. But I saw some vehicle, and I'm thinking, what is the best price I can pay for this vehicle? What would it be?
The data is continuous. Technique will be regressions only.
Regression. So just a change in the question. Should I buy this vehicle? That is one question. The second question, okay, I decided to buy this vehicle. What is the best price I can pay for this vehicle? Now I cannot say yes or no here. What is the best price? Yes. Doesn't make any sense. What is the best price? $2,000. Yeah, that makes some answer. So in this case, it becomes regression. So always think about the answer. What is the question you want to answer? And what could be the possible answers? If the possible answer is a continuous variable or continuous value, call it as a regression. If it is a categorical variable, call it as a classification. Now, which fruit we eat? It could be one of the different 100 different varieties, either apple, banana, whatever it is. Again, this is a classification. Which of the many technologies to use? I have 100 different technologies: Java, Groovy, Scala, Python, data science, data analysis, whatever it is. Which of the many technologies to use? All of
Regression.
them are. Where is it regression?
I mean, technologies will be multiple technologies.
Yeah.
So we choose based on its influence. We choose this technology is better. So
Yeah. What is the answer? Which of the many technologies to use or to learn? That is your question, right? Original question.
yeah, yes.
To learn, not use.
Oh, sorry, it's not regression. It's classification. I'm sorry.
Yeah, I'm not predicting saying 100. Did I say that?
No, sorry.
I did not. So it is a
Yeah.
classification. Now, I told you that most of your decisions will be classification. Why is that? Because it is nature. I cannot have any answer for that. But you can see from many different questions that you asked, most of them are classification. Only one of them, which I gave you as an example, one of them is regression. Most of them are classification. So many of your decisions that you take in real world are going to be classification. Very few of them that you see in real world are going to be regression. Okay, agreed? Because I cannot answer this question. If you ask me why most of the questions, most of the decisions are regression or classification, there is no answer. It is because of the nature. The nature allows us to think in terms of classification better than regression. So that is only based on the nature. I do not have really an answer why classification is more likely to be decision. But I proved you that I asked you to ask questions. I did not ask the questions. All of these questions, except the last one, you framed these questions, and all of them are classification. Okay, that is how I can prove that classification are more likely to come up as a business decision. Whether it is a business decision or your personal decision, it is more likely to be classification than regression. Okay, are you clear why classification are going to be more likely? Because that is how generally you think. Your brain thinks in terms of classification more likely. Are you clear? For
Yes.
example, even it is not natural way to think best price for your vehicle. If you have a mathematical model, probably it will work. But let's say I gave you 100 different vehicles or 100 different vehicles and asked you to find out for vehicle number 101 what is the best price. You'll tumble. You'll not be able to you'll not be able to think how can I arrive at some best price. You'll not be able to visualize properly. But the same question, if I have 100 different vehicles and I asked you to pick one vehicle, which vehicle you should buy, which is a classification. Should I buy first vehicle? Yes or no. Should I buy second vehicle? Yes or no. If I gave you 100 vehicles and asked you to pick one vehicle which you want to buy, you'll be able to buy. I'm sure about that, because it is very easy to classify things mentally. Your brain works that way than for regression. Is it clear? Why is it so natural? Classification?
Yes, Sandeep.
Yes, Sandeep.
Okay. Let's take a break. Actually, I did not plan to talk about this, but I felt this is a more natural way to talk about why classification is more important, so that you will also focus on what is more important than what is less important. Okay. You may ask me, okay, well, then why did you talk about regression for maybe 1 month? Did we talk? I don't know. Why did we talk about regression for 1 month? The answer to that question is only when you understand regression, you can understand many other topics like cross validation. Okay. Why do we need uh, train test validation data sets? What is y hat? All those things naturally comes when you understand regression. Okay. It doesn't mean that regression is useless technique. It is still useful technique, because for example, tomorrow you may decide to buy a stock. So the first question you may ask me is, should I buy Google stock tomorrow or not? That is the first question you may ask me. But the second question is, how much should I pay for that stock? Again, regression comes into picture. So it's really not useless technique, but in reality, you'll see lesser amount of regression techniques, more volume of classification questions that you need to answer. Okay, it's still not useless technique, and I don't suggest you to shy away from using regression. You should still use regression technique, but only appropriately. Okay, so that's about the decisions that you take in real life. Let's take a break of 5 minutes or 6 minutes. We'll come back at 7:30. We'll come back. Okay.
Sure, Sandeep.
Okay. Is everyone back?
Yes, Sandeep.
Yes, Sandeep.
Okay. Now we want to replace this intelligent system with a decision tree, which is one of the classification technique. We actually have many other techniques. For example, let me write down whatever we are going to discuss. Classification techniques. We already talked about logistic regression. We are talking about decision trees. We will talk about random forests. We'll also talk about K&N classifier. Then we'll also talk about K&N decision tree SVM. Which is a short form for support vector machine. Don't get too much worried about the name. The name itself is very big, but support vector machine is very easy technique. Yeah, I think these are what we'll talk about in classification. In regression, actually, we already completed regression. We already talked about all the techniques that are required. We talked about simple linear regression. We talked about multiple linear regression. We talked about polynomial regression. Polynomial is nothing but x square, x cube that we tried out. I just did not name it. Otherwise, it is nothing but polynomial regression. Ridge regression is something that we talked about. Lasso is something that we talked about. So all these techniques we have touched upon or even talked in depth. So similarly in classification, we are going to, this one is done. We are doing the decision trees and remaining things will complete upon. There is also neural networks. We'll just briefly touch upon neural networks. Neural networks is something called, there is a, neural networks is as big as whatever we covered till now. So what we do is we'll go through neural networks briefly. So there are many other techniques in neural networks that we're not going to go through because that is a separate subject called deep learning. So we're not going to deep learning mode at this in this course, but we are going to touch upon what is neural networks, and we are going to solve a problem on neural networks also, but we are not going to too deep into deep learning. Okay, that's what we're going to cover. So we are going to cover these techniques in the rest of the classes. Any questions?
I'm clear, Sandeep.
Okay. Now I know that I have to build a tree, and I know that the tree works for any given application. If I process the application through this tree, I'll be able to predict whether it is a safe loan or a risky loan. Now the question is how to build this tree. How do I build this tree? So to build the tree, I'm going to get a training data. I'm going to optimize some metric. I don't know which metric is it. Probably it is an accuracy metric, or is it an F1 score, or is it a precision or recall. One of the metric I can choose and try to optimize. What does it mean by optimize? So for example, accuracy. How do you optimize accuracy? Should you increase accuracy or decrease accuracy? You should always increase the accuracy. You should get a maximum accuracy on the tree. So find a tree that maximizes the accuracy. If you choose the quality metric as F1 score, then you should say you should optimize the F1 score. What does it mean? F1 score should be the maximum value. So if it is MS residual, for example, instead of classification in this tree, let's say I'm doing regression. If MS residual is my metric, then I should decrease the metric. When I say optimize, it should be at the minimum value for MS residual. So each metric should be either maximized or minimized. For accuracy metric, if you use accuracy as a metric, you should increase. F1 score, it should be maximum. Precision, it should be again maximum. MS residual, it should be minimum. So each metric either should be maximized or minimized. Choose a metric. For now, let's consider accuracy as a metric. So if it is accuracy as a metric, then you should maximize the accuracy. There is another metric that is defined here. This is called classification error. What is this classification error? Number of or fraction of mistakes that you have in your tree. So fraction of metrics means total number of incorrect predictions by number of examples. So for example, out of 10 examples or 10 training examples, if you have 3 of them incorrectly predicted, then your classification error is nothing but 3 by 10, or you can call it as 0.3. So the best possible value is there are no incorrect values at all. This is 0. And out of all the examples, which means 0 by some n is going to be 0. So the best possible classification error is 0. And the worst possible classification error is all the examples are incorrectly predicted. So the numerator is same as denominator. If that is the case, then all the predictions are wrong, which means the worst possible value is 1. So that is how I can define the classification error. Now, if classification error is the quality metric that I have chosen, then if I have to optimize it, should I have a maximum classification error or minimum classification error? Which one should I have? Should I have a maximum classification error? Should I get a tree with maximum classification error or minimum classification error? I should get a tree. Yeah, someone opened mic.
Oh no, I was just gonna say minimum.
Yeah, minimum. You are going to get a tree with minimum classification error, obviously. So you minimize this classification error. Now find the tree with lowest classification error. Now how do you find the tree? You have multiple different options. For example, let's say this pink one is saying about income. This blue node is about, let's say, what is the other one? You have term. Yeah, term is the other one. And the black one is saying about, let's say, what are the three ones? There is a third one, right? Credit history. Okay. So how many trees are possible? That we will try to understand. So the first one is, maybe you start with income, then you go with other two. Or maybe you start with term and you divide it into other two, which is income and credit. Or maybe you start with credit history itself and continue with others. Similarly, you start with income, but you divide the data set more on credit history than the other one, which is the term. So there are multiple possibilities that are available for you. You have to try out all the different combinations of having that, building this tree. Out of all those best tree, out of all those combinations, find out the classification error for each of the tree. For example, for this tree, let's say classification error is 0.4. Let's say for this tree, the classification error is 0.7. This is 0.8. This is 0.3. This is 0.25. This is 0.2. Which one is the best tree? Which one should I pick? T5 is what I have to pick. Fifth tree. Because this is having the minimum error. Sorry, not T5, T6.
Point two, right? Yeah,
T6, sorry, T6. T6 is what I have to pick up because it is having the minimum error. Okay, but the question is, how many trees should I build? The problem is, with this approach, the number of trees is exponential to the number of variables that you have. If you have 3 variables and the first variable is having 3 different categories, second variable is having 2 categories, 2 types, third variable is having two different values. Is it 2 or 3? Yeah, 2 different values. So this is having 3 different values. What are those? Fair, poor, excellent. This is having 2 different values. And this is having 2 different values. The number of trees you can build is 3 into 2 into 2. How much it is? 12. Now, the moment you add more variables, the number of trees that you have to build is going to be increasing exponentially, like this. By adding variables, like this, it will increase. This is what is called exponential curve. Like this it will be. If you remember our previous discussion on standard functions, where is that? Yeah, in regression I mentioned this. If you see the visualization of standard functions, see the exponential curve, how it is growing. From 0, it gained traction very slowly, but after some time it grew very quickly. The amount of growth it has after 6 or 7, it is too much. On y-axis it was like 5,000, 10,000. It went up to 20,000 just from 6 to 10. So this is called exponential curve. And you need to remember these curves, how these curves will look like. Okay, each of these curves. That is the reason why I mentioned this about this visualizations of standard functions. Now, This exponential curve, you can see that it is increasing too much, which means the number of trees that you have to build, the moment you have more variables, here I have only 3 variables. The moment I have 4 variables, 5 variables, 6 variables, the number of trees I have to build is going to increase exponentially. And it is a problem. Why is it a problem? Because I have to build large number of trees, very large number of trees. If I have to build a very large number of trees, then it is very hard to compute all those classification errors. Building those trees, all those things are going to be very hard to build, because you're repeating this building of trees for maybe, let's say, 1 million times or 1 billion times. Now doing this for 1 billion times means that your computer is not going to complete the task it is given within a finite amount of time. Maybe it takes 3 years or 5 years or 10 years. If computing those many number of trees is taking 10 years, then it is a useless model. So how to find the best tree? So this kind of a problem, which you cannot solve using a computer as well, is called NP-hard problem. Okay, in computer science it is called an NP-hard problem. NP is nothing but non-polynomial. NP means non-polynomial, which means there is some exponential problem there. So when there is a NP-hard problem, you cannot solve that problem using a computer. You cannot use a computer to solve the problem, because even using a computer, it will take years to compute. Now, what is the usefulness of this decision tree? After 10 years, if it computes some, let's say, I'm an investment banker or I'm a normal bank and I want to give loans. For that, I asked a data scientist, and the data scientist said that to build this decision tree, it will take 10 years. What is the usefulness of that model? It's not useful at all. If something takes more than, I would say on computer, if something takes more than an hour, it is a useless model. Forget about years. So then how do you find the best tree? So it means that I cannot find the best tree by extrapolating all the possible trees that I can ever build. And based on all of those, I cannot find all the classification errors and find the best tree. This is not a feasible method to solve the problem. So the other problem is called, the other way to solve this problem is called greedy algorithm. So instead of finding a best tree, I am finding a good enough tree. How do we find a good enough tree? So that is using this greedy algorithm. What you do is you start with an empty tree, which means it will have only root. So at root, what you do is compute in your training data, in your entire training data, compute the number of safe loans, number of risky loans. Okay, compute the number of safe loans, compute the number of risky loans. Based on the safe and risky loans, just say, let's say in your entire training data, there are 20 safe loans, 15 risky loans. Just keep that in your root node. Keep that in the root node, saying I have 20 safe loans, 15 risky loans. Now, try to split on one feature. Feature means, feature is nothing but variable. Okay, from now onwards, in machine learning world, you most likely don't call it as a variable. Each column you don't call it as a variable, you call it as a feature. This is income feature. Instead of calling it as variable, I call it as income feature. Similarly, term feature, credit feature, both are same. It's only a difference in the terminology. Now you take a feature, split the data on that feature. For example, now I took credit as the feature. You split your data on credit. How do you split? If credit equal to excellent, compute all the data points where you have safe loan, where you have risky loan. Let's say this is 5, this is 0. Similarly, on fair, when credit equal to fair, compute all the data points where the training data is saying credit equal to fair and it is a safe loan. Let's say this is 4 and this is 2. And again, you count the number of safe loans when the credit equal to poor and it is a risky loan. And when credit equal to poor and it is a safe loan. Let's say this is 1, this is 4. You just keep the counts in the, after splitting, you keep the counts in each of the branches. Okay? Are you clear so far?
Yes, Sandeep.
Okay. Now, how to make predictions? Let's say if I want to predict after splitting on first feature itself, how to make the prediction? For example, here I have safe and risky loans. 1 safe loan, 4 risky loans. Four risky loans I gave, 1 safe loan I gave. Here in this node I gave 4 safe loans, 2 risky loans I gave. Here I gave, when credit equal to excellent, I gave 5 safe loans, 0 risky loans. Now how do I predict? Here both, at least here I can say there is no risky loan when the credit equal to excellent. I can always predict here as safe if I want to predict here itself. Yes or no?
Yes, Sandeep.
For example, if I want to predict here, how do I predict? Here actually 4 safe loans I give. When credit equal to fair, 4 times I gave safe loans, 2 times I gave risky loans. Now which one should I predict? So the answer is predict the majority class. What is the majority class here?
Safe.
Safe. Predict that one. What is the predict majority class here?
Risky.
Risky. Just go by the simple majority. Whatever is the majority, go with that. Okay, that's what he was saying here. But the problem is predicting safe here is not same as predicting safe here. Why is that? Here there are some risky loans also. You are not considering them and you are immediately predicting it as safe loan. This is not proper because this is not exactly same as this one. Are you getting it or not? Here there are no risky loans, all are safe loans. That's why you can easily say that it is safe loan. But here there are some risky loans as well. It's not always safe that when credit equal to fair, you cannot always say that it is always safe. Sometimes it may be risky also. Here also, you cannot always say when credit equal to poor, you cannot give the loan at all. Sometimes it is safe as well. So predicting safe in this node is not exactly the same as predicting safe here. Yes or no? Are you clear or not?
Yeah, I'm clear, Sandeep. Yes, Sandeep.
Okay. Vijay, are you clear?
Yes, Sandeep.
Second, let me remove all this nonsense so that it will be clear for you in the, if you want to read. Okay, this is here, this is for this, the 4, and here I mentioned 2, I think. Yeah. So here predicting risk is safe is not really correct. Predicting risk is also not really correct. What should you do then? What you can do is, instead of predicting here itself, you can further split. This one also you can further split on some other variable or some other feature. But when credit equal to excellent, there is nothing to split. It is already everything is safe already. When credit equal to excellent, always give loan, because there is no risky loans at all according to the past history. But when it is fair or poor, you cannot decisively say either it is safe loan or risky loan. So what you should say is, either you can predict here, which is not really correct, or what you can do is you can further split on some other variable. Let's say credit you are already done. Let's say maybe income or term. Use another variable and try to split the decision tree again. So here all the examples are safe loans. Then predict safe always here. What about fair and poor? These are not really always safe. This is not always safe or really. This one is also not always risky. So what you should do is you should take another variable, again try to split. So how do you know that which node I have to split, which node I cannot split? So if I get, after splitting, if I get a node which has all the examples of one category, in this case all the examples are safe category, then I call it as pure node. And these are obviously an opposite of the pure node, which I can call it as impure nodes. These two are impure nodes. So when you have an impure node, split it again. Pure node means it is purely safe. This one is purely safe. This one is safe, but not very pure. This one is risky, but again not very pure. So these two are not pure nodes. So when you are having an impure node, split the data again on these two branches, these two nodes. How do you do it? Again, build a tree, subtree from here. So maybe you call it as, let's say, you start doing on income. On income, you can say either high income or low income. Again, you count number of safe loans here, number of risky loans here, and again you count here also safe and risky loans. So from fair, you got another branch of the tree. Similarly, from poor, you may get another branch. Maybe this time you took, instead of income, you took term. When it is 3 years, you get another branch. When it is 5 years, you get another branch. You keep on doing this until when? The question is, until when? Are you clear so far how to split again?
Yes, Sandeep.
So when you keep on splitting, what is the algorithm for this? Start with an empty tree. That's what we started. Select a feature to split. The question is, how do we select this feature? Problem number 1 is feature split selection. Which feature should I select? Here I randomly selected credit, but I don't know. It may not be the best one, or it may not lead to a good tree at least. So I'm not talking about the problem one first. First I'm talking about what is the algorithm. Start with an empty tree. Select a feature to split. For now, let's say I randomly selected one feature, but we'll get to know how we are selecting the feature. Then for each split, if nothing more to split, Because when will we get nothing more to split? If all of them are one category, why do you need to split? So that's why you don't split. Then make predictions directly. Otherwise, go to step 2 and continue recurse on the split. What does it mean? You split again on this. From this branch, you select another feature. This time I call it as income. On this income, you again try to split. That's what is called recursion. You do the same thing again and again. When you do the same thing again and again, it is called recursion. So you do recursion and try to split on another variable. You keep on doing this until each node you get is a pure node. Every node you get is a pure node. You keep on doing that. Okay. Now the problem number 2 is when to stop. Should I stop after getting all the pure nodes, or is there any other stopping criteria? So now we have two problems. One is, how do you select the best feature always when you're splitting, and when to stop the splitting? Are you clear so far?
Yes, Sandeep.
Vijay, what about you?
Yes, Sandeep.
Okay, that's all I have for today. We'll catch up tomorrow. I think I gave you a homework. Did I give you?
Yeah, I sent that about the decision tree.
Is it? I'm sorry. Maybe I didn't see.
Oh, it's okay. It was very sloppy the way I sent. I'm sorry about that.
What about you, Abid?
No, not yet, Sandeep. I will do it after this class, and I will send you.
Yeah. Yeah, you can see when outlook equal to overcast, if it is true, you get 0, 4. If you see this one, this is a pure node. When it is not true, when outlook is not overcast, then we are getting 5, 5. What is this 5, 5? It is saying 5 times you can play golf, 5 times you cannot play golf. Which it simply means that it is not a pure node. This is a pure node. Again, because of that, you started splitting. Because this is a pure node, you did not split again. Again, you tried to split again. 4, 1. 4 times you did not play golf. 1 time you played golf. Here it is 1, 4. Again, both of them are not pure nodes. Again, you split. This is a pure node. This is a pure node. But these two are impure nodes. But it still stopped. Okay, which means we still do not know what is the stopping criteria. When should I stop? In this case, the decision tree stopped here when there is a 1, 1. But I do not know when to stop. Why did it stop at that moment? So that is something we'll talk about tomorrow. Is it interesting or it is completely boring?
No, it's interesting because logically you're making decisions.
Yeah. Okay. We'll try to understand the remaining things tomorrow. Okay. We'll catch up tomorrow. Bye.